Alright, so the nth term of 6 different sequences are 7n minus 2, 10 minus n, a half n minus 3, and n squared plus 1, 60 over n, and 2 to the power of n. Calculate the first 4 terms of each sequence. Okay, so that's a bit of busy work. Okay, so the first sequence is going to be 7 times 1 minus 2. The next one's going to be 7 times 2 minus 2. Next one's going to be 7 times 3 minus 2. And 7 times 4 minus 2. The first one is going to be 5. The next one's going to be 12. The one after that's going to be 19. And the one after that should be 26. Okay, that's the first one done. The next one, which is underlined in red, we get the T1, T2, T3 and T4 here. 10 minus 1 is the first one, is 9. 10 minus 2 is 8. 10 minus 3 is 7. And 10 minus 4 is 6. Okay, the next one is a half of n plus minus 3. So we have T1, T2, T3, T4. This time it's in green. Okay, a half of n. So a half of 1 minus 3 is minus 2.5. The next one, a half of 2 minus 3 is minus 2. A half of 3 minus 3 is minus 1.5. And finally T4 is a half of 2 minus 3, which is minus 1. You can see that the gap between each series is the same, isn't it? Yeah? Might not be the same for the next one though. So number D, n squared plus 1. Let's figure out this one. T1, T2, T3, T4. So it's n squared plus 1, right? Yeah. So 1 squared plus 1 is 2. 2 squared plus 1 is 5. 3 squared plus 1 is 10. And finally 4 squared plus 1 is 17. There's no common difference here, is there? The first gap is 3, the next gap is 5, the gap after that is 7. Therefore it hasn't followed the pattern of the previous sequences. Alright, finally 60 over n is the next one. 60 over n. We'll do this one in blue. Okay, so 60 over n. We'll do it in blue. T1, T2, T3, T4. 60 over n. So 60 over 1 is 60. 60 over 2 is 30. 60 over 3 is 20, and 60 over 4 is 15. Once again, the gap is different every time. It's 30, then there's a gap of 10, then there's a gap of 5. So it's a bit irregular, okay? Now, 2 to the power of n is the last one, and we'll do this one in black again. So Tn equals 2 to the power of n. First one is T1 equals 2 to the power of 1, which is 2. T2 equals 2 to the power of 2, which is 4. T3 ends up to be 2 to the power of 3, which is 8. And finally T4 is 2 to the power of 4, which is 16. To calculate the 20th term in each sequence, all I gotta do is replace n with 20. So T20 is 7 times 20 minus 2 for sequence number 1, which is going to be 138. T20 for the second sequence is just replace n with 20, so you're going to get 10 minus 20, which is minus 10. For the green sequence, For the green sequence, T20 means replace, it's going to be a half times 20, so T20, remember a half times n, so it's a half times 20 minus 3, which is 7. Okay, D, which is in purple, okay, so D, which is in purple, what we can do is replace n with 20, and we're going to get 20 squared plus 1, and 20 squared plus 1 is 401. Okay, and then T20 for the blue series, which is 60 divided by n, is going to be Tn. T20 is 60 divided by 20, which should equal the number 3. And then finally, the last series, which is T to the power of n, T20 is going to be 2 to the power of 20. And does anybody have a calculator to do that one? 2 to the power of 20. So that's your number there, 1048, 576, if I can remember. Yeah. Okay, how many people got those ones out for T20? Okay, the majority of the class. Alright guys, which of these sequences are linear? What does linear mean? What does linear mean, can anybody tell me?
Go up by the same amount.
Go up by the same amount or go down by the same amount. Is the first one linear? Is A linear?
Yeah.
It is, because there's a gap of 7 every time. Okay, is T2 linear?
Yeah.
Goes down by -1 each time. Is C linear, the green one?
Yeah.
2.5 goes down to -2. -2 goes down to -1.5. 1.5 goes down to -1. It means you're adding on a half every time. It's also linear. Is D linear? Which is the purple one. The gaps aren't the same. Although there is a pattern there, there's no pattern between the first gap, so no. Is E linear? No. And is F linear? Is the gap the same? No. So, that one ain't linear either. Okay. Okay guys, next one. The linear sequence can be found on this, linear sequences can be found on this grid. 2 are shown in the diagram. 3, 6, 9 and 12, and 6, 11, 16, 21, 26, 31, 36. Find 7 more sequences that have 4 terms or more. Okay. I'm going to underline this one here. Can anyone tell me what this one does? Goes down by 10 each time. Okay. Let me see another one. Now we're looking for diagonals even. I use different colour. What about this one here? Anybody? That one there? 40, 37. Oh wait, it's not, excuse me. There's no sequence there, don't mind me. Seeing things that are not there. Okay, let's keep looking. Can anybody else see anything other ones? What about this one here? What do you think? 7, 6, 5, 4, 3 and 2. That'll do me. Can anybody spot any other ones? Any other ones? Just remember, it says write down each sequence as an increasing sequence of numbers. So this one should be 2, 3, 4, 5, 6 and 7. Now what Oscar was saying there was we have this one here that goes up in sevens. So we have 23, 30, 37 and 44. Does anybody see any other ones? Yes.
On the bottom right hand corner, 0, 1, 2. Oh no.
0?
No, it's
No, that's not. Okay, any other ones? Yes.
well, the one you just did keeps going.
This one?
Yeah.
Oh, 8.
Because then, no, it was the 44.
8, 9. All the way up. Yeah. 4 terms or more, so that would count as well. Have a look. Sorry, Tyler, what are you telling me to do now?
The last one you did keeps going down to 2.
Ah. So it keeps continuing all the way down, so that could be another one. Okay. Any other ones? Now, if you're looking for 7 more linear sequences, okay, the question can be slightly ambiguous, as in maybe you could just continue it onwards. So it does 2, 3, 4, 5, 6, 7, 8, 9. Does that count as a different one from the one we just did? That's sort of question that the question doesn't include. So we don't know if it is or isn't a different answer. Okay. Now what we can also see on these is the following. We can see, if you look at the green, we can see 4, sorry, what did you say again, Jack?
4, 10.
4, 10, 16, 22, 28, 40, so that one there. So that's another one, 4, 10, 16, 22, 28, 34, 40. Another one is this one here, 3, 5, 7 and 9. So 3, 5, 7 and 9. Does anybody else see anything else on board?
On the left hand side, 4. On the bottom, like far left.
Far left. Here.
Yeah, the 4 and then the 7, 10 and 13.
4, 7, 10 and 13. And yes.
4 on the right hand side, the purple.
Yeah.
Diagonally.
4, 8, 12, 16. Okay guys, I think we all get the gist of what we're looking for here. It's getting horribly messy there, so you just gotta keep track of what you're doing with a straight line is the best way of doing it. Okay guys, the expressions below give the end term of these sequences, matching each expression to its sequence. Okay, this is a difficult one. Okay, so we have a couple of sequences written down and we can see how to do this. So the first one here is going to be going up in threes, right? So it's going to be 3, 6, 9 and 12. Do we have a sequence that goes up 3, 6, 9 and 12? Let's have a look. 3, 6, 9 and 12. So something that goes, oh there it is there. 3, 6, 9 and 12. So that's the first sequence. What about 6n minus 2? 6n minus 2. What's the first terms there? It's going to be 4. The next one's going to be 10. The one after that is going to be 16 and 22. Do we see 4, 10, 16 and 22 anywhere? There is there. 4, 10, 16, 22. So we've matched up that sequence as well. Okay? What's the next sequence we have? 10n minus 6. 10n minus 6 goes 4, 4, 14, 24, 34. Does anybody see that one? 4, 10. Where is it? This one? 4, 14, 24. So we've matched that one up as well. Next one, 2n plus 1. 2n plus 1 is 2 times 1 plus 1, which is 3. The next one is 5. So it's 3, 5, 7 and 9. Do we have a 3, 5, 7, 9 anywhere? Where is it? There is there. the green diagonal. So we've matched that one up as well. Does everybody get the gist of what we're doing? We're just finding the sequence and matching up to the diagonals up above, right? So it's easy enough. Okay. There are two ways of doing the following one. The following one can be expressed in two ways. Okay. Okay, so the following one can be done in two ways. The first way to do it would be to keep going. What's the gap between each one? The gap between each one is -3. So what you could be well entitled to do is the following. You could be well entitled to just keep counting down. Now, can anybody give me a problem with this method? What's the problem with this method if I just keep counting down over and over and over again? It's time consuming, and eventually they might give you such a big number that you basically haven't got the time, as you said, time consuming, you haven't got the time to count down to it. So, but what we can do is give it a quick whirl and see if it's actually, this one wasn't actually that time consuming at all. So how many turns did it take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. There's 15 of them. Okay? I'm going to show you a different way of doing it. The different way of doing it is the Tn formula. Tn formula is A plus n minus 1 times d. Now, what is A, guys? A is the first term of the sequence, which is 8. What's the d value? D value is take away 3. Now, therefore Tn has to equal this. So you multiply in -3 and what do we get? -3 times n? Anybody? -3n. -1 times -3? Plus 3. Tn therefore must equal 8 plus 3? 11 minus 3n. If I replace n with any number, it will tell me what term that is. So let's say, for argument's sake, I wanted to find out what T6 was. How do I find out what T6 is? Replace n with, and I'd get, this is not part of the question now, that's just me showing you how it works. 11 minus 18, which is -7. So does the formula work? It does. Now, what we're asked to find out is, we're asked to find out Tn equals -34. How would we do that? T minus 34 would mean replace n with -34. That doesn't say -34 here, does it? No. So what does it mean? It means the formula for Tn equals -34. So what this would mean is, what's the formula for Tn? 11 minus 3n. 11 minus 3n equals -34. Bring over to 11. Minus 3n equals -34 minus 11. Minus 3n equals -45. 3n equals 45. N equals, anybody? 15. Okay? So that's a more complicated way of doing it, but it's actually the more necessary way of doing it. Okay?